We're going to take a look at elimination. Elimination is another way to solve a system of equations. System of equations is any time that we have two equations that would be graphed, and the answer is the point where the two graphs would intersect each other. We don't like to use graphing because if you graph, there's a lot of human error that's involved where we may mess up and it looks like it intersects somewhere where it doesn't, or it intersects and it's not directly on a point, and we can't tell exactly where the intersection is, and we end up having to guess. Well, the two ways to solve systems without graphing, substitution, which we've talked about before, and then here elimination, give us an exact answer. Now, between substitution and elimination, elimination tends to be the student's most favorite way to do it. So we're going to take a look at this. Now, in order to do elimination, first off, everything has to line up. If you look at this problem, notice that my x's line up, my y's line up. Most importantly, my equal signs line up. Okay, and then the constants also line up. So everything has to line up. Once you line up, then you have to look to see if you can eliminate one of the variables. Well, if you notice, my y's are set up to be eliminated. If you combine a 3y with a negative 3y, then they would cancel each other out. So what we're going to do here is we're going to cancel these out and end up with 6x is equal to 24. At that point, now we can go ahead and we can solve for x by dividing by 6, and we have now found our x coordinate of 4. Just like when we were doing with substitution, anytime that you have an answer, you always have to have your x answer and your y answer because the solution is the point where they intersect, and that's what we're finding here. So the x coordinate to where they intersect is 4. Now I have to go back and I have to find my y coordinate. So I'm going to go back and we're going to plug in. You can plug in either to the top or the bottom equation. It doesn't matter which. You'll get the same answer either way. I usually like to pick the one that has the fewest number of negative signs. So I'm going to choose the top. So I'm going to go 4 in parentheses. I'm going to plug in a 4 in for my x plus 3y is equal to 16. 4 times 4 is 16 plus 3y is equal to 16. And now we got to get y by itself. So we're going to subtract 16 from both sides. Those cancel, and we have 3y is equal to 16 minus 16 is 0. Divide by 3, and y is equal to 0. So the point where these two lines intersect is going to be 4, 0. Okay. Now, obviously, as a good teacher, I always show you the easiest way first, and then we'll move on to the more difficult way. So that right there was perfectly set up for us, really easy to do. The next one that we're going to look at, it's going to be a little bit more complicated. When we take a look at these, you look at your x's and your y's, and there's nothing that will eliminate. So I noticed that on my x's, right there, that 2x and x are pretty close to being eliminated. Okay, now in order to eliminate these, I need to make this bottom x, I need to make it a negative 2x. Because if the bottom one is a negative 2, then it'll eliminate with the top one, which is a positive 2. Well, thankfully in algebra, if it's an equation, which we do have, we can do anything we want to an equation as long as we follow the rules. Well, I want to multiply this x by negative 2. So I'm going to multiply this by negative 2, which is fine. You can do that. But if you multiply this by negative 2, then we have to multiply every term by negative 2. Okay, so I'm going to rewrite these. So we have 2x minus 5y is equal to 10. That's my top equation. Now on the bottom one, we multiplied everything by negative 2. So this becomes negative 2x. And then 2y times negative 2 would give me a negative 4y is equal to, and I multiplied that by negative 2 as well, so the 14 times negative 2 would give us a negative 28. Now when you take a look at this, my x's are set up to be eliminated. So we can go ahead and eliminate these x's. And notice in order to eliminate, one has to be positive and one has to be negative. Then we look over at the y's. The y's, we combine those and we get negative 9y is equal to, and then negative 18. So now we divide both sides by negative 9 in order to solve for y, and y is equal to 2. All right, so that's my y coordinate, but once again, I need to find the x coordinate as well. I'm probably going to plug it into my bottom equation right here, the original one before it was multiplied by negative 2. So I'm going to go x plus 2 parentheses, and I'm going to plug in a 2 for y, is equal to 14. Now, 2 times 2 is 4, is equal to 14, minus 4 from both sides, and x is equal to 10. So the point where these two intersect are 10 and 2. Okay, looking at another problem. Once again, going a little bit more difficult now. This one right here is typically as difficult as it gets. Neither the x's or the y's are set up to be eliminated, but the problem here is that let's say I chose the y's. If I want to eliminate the y's, I could not just say, well, I'm going to multiply 2 by 2 and get 4, because I need to eliminate with 3y. So what we're going to have to do is we're going to have to find a common number. It's referred to as the least common multiple. And in this case, our common multiple for 2 and 3 would be 6. Now, not only do I need a common multiple, which I have, but one of these has to be a negative. If you notice right now, both of my y's, okay, both of them are positive. So I'm going to choose for the top one to be negative. So if I want this top y to be a negative 6, then I'm going to multiply it by a negative 3, because negative 3 times 2 would give me a negative 6, which is fine. I can do it, but now I got to multiply every part of this equation by negative 3. That would give me negative 9x minus 6y is equal to a positive 36. Okay, going back to that bottom equation now, if we got the top one to become a negative 6y, we want the bottom one to become a positive 6y. So I'm going to multiply this by a positive 2, so I'll make it a positive 6, which is fine, but we have to multiply all of these by a positive 2. So that gives me 8x plus 6y is equal to 8. Now we're set up for elimination. My y's will now eliminate, and we're left with negative 1x is equal to, and that would give me 44. Divide both sides by negative 1, and x is equal to negative 44. Once again, that is just my x coordinate. So I'm going to plug this back in. I'm going to plug it into my top equation. So we're going to go 3 parentheses, negative 44, substitute that in for x, plus 2y is equal to negative 12. Multiply those two together, and we have a negative 132 plus 2y is equal to negative 12. And now we want to get y by itself, so I'm going to add 132 to both sides, and we have 2y is equal to 120. Divide both sides by 2, and y is equal to 60. So the point where these two intersect is negative 44 and 60. Okay, the last one, in order to work this one out, we're going to have to get these set up so that everything lines up. So far, all the ones that we've done have already lined up for us. But if you notice here, the equal signs don't line up. The y's and x's kind of do. It seems like everything's lined up, but because the equal signs aren't lined up, I'm going to have to manipulate this a little bit. So what I'm going to do is I'm going to take this y, and I'm going to want to move it over to the left-hand side. So we got negative 4x is equal to 2y minus 6. So in order to move that 2y, we're going to get rid of it on the right-hand side and get it over to the left-hand side. So that cancels out, and we're left with a negative 4x minus 2y is equal to negative 6. So now if I rewrite my bottom equation, we've got 4x plus 3y is equal to 16. And we are set up for elimination now. So these will eliminate, and we get 1y, or just y, is equal to 10. And we can now substitute that back over, and I'm going to substitute it into my top equation because it's pretty close to having x by itself. So we're going to go negative 4x is equal to 2 parentheses, substitute the 10 in for y, minus 6, and get negative 4x is equal to 20 minus 6. And then 20 minus 6 is 14. Divide both sides by negative 4, and x is equal to, that reduces to a negative 7 over 2. So my answer would be negative 7 over 2 and 10. You could have used substitution there if you would have got the x by itself, but a lot of kids still think that elimination is easier.